This video lecture will cover a portion of section 5.3, multiplying polynomials. By the end of this video lecture, you should be able to use the distributive property and the FOIL method to multiply polynomials. Our first example asks us to find the product of a polynomial and a monomial multiplier. So here our first problem has 5 minus y times 2y. So we have the polynomial 5 minus y and a monomial multiplier 2y. So what we want to do is we want to take the monomial and multiply it by each term of the polynomial. So we have 5 times 2y. And then we have the second part of the polynomial, we have minus y also times 2y. So 5 times 2y, we get 10y. And we have negative y times 2y, so we have minus 2y squared. And that's our final answer for this first question. In our second question, we have 4x, a monomial, times 2x squared minus 3x plus 5. So a three-term polynomial. So we want to take the monomial and distribute it to each term of the polynomial. So here we have 4x times 2x squared. We keep the sign the same, so minus sign. We want to take the 4x and multiply it by 3x. And then keeping the sign the same, we want to have the 4x, and we want to multiply that by the positive 5. So here we have 4 times 2, that's going to give us 8. We have x times x squared, and as we learned last time, that's going to give us x to the third. We have 4 times 3, so that's going to give us negative 12. X times x is going to give us x squared. And we have 4 times 5, which is going to give us 20. And that's going to be multiplied by x. So that gives us the final answer for the second question. So multiplying a monomial times a polynomial is really just like using the distributive property. We're going to take the monomial and distribute it to each term of the polynomial. So our second example has us dealing with negative monomial multipliers. It's really the same thing that we just did, it's just now rather than multiplying each term by a positive monomial, we're multiplying it by a negative monomial. So here we're going to take the negative 2m squared and we're going to multiply it by the positive 7. We're going to keep the sign the same, so the negative that is attached to the 4m is going to stay there, and we're going to multiply that by negative 2m squared. So then 4m. We have a positive sign in the polynomial, so we're going to keep that. We're going to multiply negative 2m squared by the 2m squared on the inside the polynomial. So now that we've completed the distributive property, we're just going to multiply the terms out. So we have negative 2 times positive 7, that's going to give us negative 14m squared. We have a minus sign, but then we have negative 2 times positive 4, so that's going to give us minus negative 8, so that's going to give us a positive, so plus 8. We have m squared times m, so that's going to give us m to the third. Then in the back we have positive times a negative times a positive, so negative 2 times 2 is going to give us negative 4. So we have negative 4. And then as we learned last time, we have m squared times m squared, and so we have Same base, different exponents, so we add the exponents together, so we have m to the 4th power. So the final answer to that first question is negative 14m squared plus 8m to the 3rd minus 4m to the 4th. So same thing down at the bottom question. We have the negative 3a squared. We're going to multiply that by the positive 8. We're going to keep the negative from the polynomial. We have negative 3a squared. We have 2a because we already have the negative sign from the polynomial. We keep the negative from the polynomial. We're multiplying by negative 3a squared. And the a squared from the polynomial. So we have negative 3 times 8. That's going to give us negative 24. We have a squared. We have 2 negatives, so that's going to make this middle term positive. We have 3 times 2, which is going to give us 6. And we have a squared times a, which is going to give us a to the 3rd. We have 2 negatives in the back term, so that's going to give us a positive. And we have 3 times a squared times a squared, so that's going to give us 3a to the 4th power. So our final answer for the second question here is negative 24a squared plus 6a to the 3rd plus 3a to the 4th. So, just a review of the FOIL method of multiplication. Here we're multiplying two binomials, 3x minus 2 times 2x plus 7. So the FOIL method says take the first terms, multiply them together. Then take the outer terms, multiply them together. The inner terms, and then finally the last terms, and then combine them with addition and subtraction. So let's take a look at what this looks like. So the first thing that we want to do is we want to multiply the first terms. So we have first times first. So we're going to take the 3x and we're going to multiply that by 2x. Okay, then we're going to add the outer terms. So we have 3x times positive 7. And then we're going to add to that the multiplication of the inner terms, the negative 2 times the 2x. And then finally we're going to add to that the multiplication of the last terms, negative 2 times positive 7. Once we have this, then we're able to combine like terms. So we have 3x times 2x. So 3 times 2 gives us 6. The x times x gives us x squared. We have plus 3 times 7 is going to give us 21 times x. We have negative 2 times 2x, so that's going to give us a minus 4 times x. And then finally we have negative 2 times 7, so that's going to give us a minus 14. Now the last thing that we want to do is combine these like terms in the middle. So we have 6x squared. We have plus 21 minus 4. So that's going to give us plus 17 times x minus 14. And so this shows us the FOIL method for multiplication of binomials. So let's go ahead and use the FOIL method to find the product here. We have x times x, which is going to give us x squared. Outer times outer, we have x times 4, so that's going to give us plus 4x. Inner times inner, plus 2x. And then last times last, we have positive 2 times positive 4, so that's going to give us plus 8. And then we just want to tidy up the inner terms. So here we're going to have x squared plus 6x plus 8. Combine the like terms in the middle. Our second question, first times first. So x times x is going to give us x squared. Outer times outer is going to give us plus 3x. Inner times inner, we have negative 5 times x, so that's going to give us minus 5x. And last times last, negative 5 times positive 3 is going to give us negative 15. So here we have x squared minus 2x minus 15. So here things are just a little bit more difficult. We have some coefficients of the variable terms in this case. So let's go ahead and walk through this. We have 5x times 2x. So that's going to give us 10x squared. Outer times outer, we have 5x times negative 6. So that's going to give us negative 30 times x. Inner times inner, we have negative 2 times positive 2x. That's going to give us a negative 4x. And last times last, we have negative times negative, so that's going to give us positive, and in this case 12. So combining like terms, here we have 10x squared minus 34x plus 12. Our second question, we have 4x times 3x, that's 12x squared. Outer times outer, we have plus 12x. Inner times inner, we have plus 21x. And last times last, we have plus 21. Combining the like terms in the middle, we have 12x squared plus 33x plus 21. So now that we've gone over the FOIL method of multiplication, that's a binomial times a binomial. Here we have a binomial times a polynomial. So in this case, what we want to do is a horizontal multiplication format. So I want to multiply the first term, the x, times each of the terms. So I have x times x squared I want to add to that x times negative 4x. And I want to add to that x times positive 6. So I've multiplied the first term of the binomial times each of the terms of the polynomial. Now I'm going to take this negative 1 and distribute it to each as well. So I have minus 1 times x squared, so plus negative 1 times x squared. I want to add to that negative 1 times negative 4x. And I want to add to that finally negative 1 times positive 6. Let's go ahead and put these things together. We have x times x squared, that's going to give us x to the third. I have negative 4x times x, that's going to give me minus 4x squared, plus x times 6 is going to give us 6x. We have negative 1 times x squared, that's going to give me minus x squared. Negative times negative is going to give us a positive 4x. And negative times positive, that's going to give me negative 6. Now, final step, we want to combine like terms. So we have like terms here and here. So writing this in standard form, I have x to the third minus 4x squared minus x squared. That's going to give me minus 5x squared. I have plus 6x plus 4x. It's going to give me plus 10x. And then finally minus 6. And so here, multiplying in horizontal format, we multiply each term of the binomial times each term of the polynomial. The vertical format is a little bit more difficult, but it's just like multiplying numbers. So in this case, we have the question 7x squared minus 14x plus 9 times the binomial 2x plus 1. So first let's just write it in our vertical format. So we have 7x squared minus 14x plus 9. And we want to multiply this by 2 times x plus 1. So it's very similar to multiplying with whole numbers. We're going to take this 1, we're going to multiply it by the 9, by the negative 14x, and by the 7x squared. So 1 times 9 gives us 9. 1 times negative 14x is going to give us negative 14x. And 1 times 7x squared is going to give us 7x squared. Now, very similar to when we multiplied whole numbers using this format, the next thing that we have to have here is we have to have some kind of placeholder. So then we're going to take the 2x, multiply it by the positive 9, the negative 14x, and the 7x squared. So 2x times 9x is going to give us positive 18x. 2x times negative 14x is going to give us negative 28x squared. And 2x times 7x squared is going to give us 14x to the third. Now we can find all the parts of our answer. So we have 14x to the third. Well, let's go ahead and combine like terms here. We have 7x squared minus 28x squared. That's these two parts. That's going to give us negative 21x squared. We have plus 18 minus 14, so that's going to give us plus 4x. And then finally our placeholder with our plus 9 is just going to give us plus 9. So multiplying polynomials in a vertical format follows the similar pattern to what we did multiplying whole numbers using this system when we first learned how to multiply whole numbers. So if we want to use an area model for multiplying polynomials, it's important to understand that multiplying polynomials really is somewhat of an area-related question. What we want to do is we want to establish some specific length and call it x. So we want to have some length that we can define as x, and then we want to set this so that we have two lengths of x right next to each other, plus we want to have one length of 1. So here you can see I've set up two lengths of some number x plus a single unit. Now since area is length times width, we want to set this so that the opposite is also true. Okay, so hopefully you can see kind of what I've done here. I've set up a rectangle so that one side of the rectangle is 2x plus 1. And then I've set up the other side of the rectangle so the length is 2x plus 1 and the height of the rectangle in this case is just x plus 1. Okay, so what I've done here is I've taken this and I've forced it to be a rectangle. Now by doing this, what I can show you is that this rectangle can be separated into several smaller pieces. Okay, so let's talk about the dimensions of the pieces that we've created here. we have this rectangle right here, which has dimensions of x and 1. So its area is x times 1, or x. That same thing can be said about this piece right here. It has x times 1, also has an area of x. And this one over here also has an area of x times 1. So in this case, if we add the three areas together, we have three pieces that have an area of x. Now this square right here has dimensions of x on one side and x on the other. So it's x times x, or x squared. And the same can be said of this right here. So we have two areas that have area x squared. And then finally, this top right piece has area 1 times 1, so its area is just 1. And so we can see that multiplying polynomials, if we do this kind of area method, we can confirm that the area of 2x plus 1 times x plus 1 is 2x squared plus 3x plus 1. And that concludes this video lecture covering the first part of section 5.3.